I'd like nothing more to get this done. So 9, 20, 19. All right. Y'all have a graphing generic functions worksheet, and they're generic because it is not something you can plug into your calculator to figure out. You have to know what you're doing. That worksheet is one-sided, and so I would recommend just putting these, the bookwork on the back would be wonderful if you would do that.
Smart.
Okay, and so you can definitely do the bookwork on the back. We have two things to do, two examples today. So we are graphing generic functions, and then we're also writing equations of translated functions. And writing equations is kind of nice because you're writing an equation. Can you check that equation? Mm-hmm. Absolutely. Plug it into your calculator and check it. Super easy to do. And also, you should know that the graphing generic functions, put some stars on that paper and make sure you save it so you can practice some more for the test, because you can bet you're about $1 that that there'll be a question on graphing a generic function, because you can't use your calculator to figure it out. You actually have to know how to do it. All right. If you want, I'm going to give you a couple minutes to sketch the graph, but don't make it, you don't need to be too detailed, really. What is important is the ordered pairs that sort of create the boundaries of this generic function. So I'm just going to write those ordered pairs down here. -4, -3, -1, +3, 2, +3, and then the last one, 5, 0. So these are just these ordered pairs, and those will be helpful. So I'll give you a minute or two. Bless you.
Bless you.
All right, so we are going to do some translating of this generic function, and you should know that this generic function had a name. Its name was y equals f of x. Sorry, I forgot to put that on there. Use the graph of f. This is the graph, y equals f of x, which is just basic function notation, that this is some generic function we call f. Now, when I look at my function notation here, we want to graph y equals f of x minus 3. I want to go back to, is it inside or outside? And the 3 is on the inside, and if it's on the inside, does it affect x's or y's? X's. So what is that x minus 3 going to do to this function?
That's right 3. Left 3.
Left 3 or right 3?
Right 3.
Oh, right 3.
It's a negative.
Remember, everything with x is always inverted, okay? Moves sort of the opposite of how it appears. We would call this a horizontal shift. Right 3 units. I would write this down. You aren't required to do it on your homework, but I promise you there are 2 problems on your test that use words. Okay? So, this is a rigid transformation, meaning the shape doesn't change at all. So it's just going to slide right 3 spaces. So I'm just going to count 3 spaces to the right for all those points. Just sliding my graph 3 spaces over. So there is my translated, horizontally translated function. All right. Letter B. Is the 4 on the inside or the outside? Outside. Does outside affect x's or y's? Y's. So what is that f of x plus 4 doing to our function? Moving it up 4. Yeah, this is a vertical shift. up 4 units. Everything with y is always easy. It says plus 4, that's what it is. It's taking these points and just adding 4 to the y value. Does exactly what it says. All right. So both of those were rigid transformations. Rigid meaning what? Stay the exact same shape. Okay. And what's going on with C and D? Okay, A and B were called rigid. C and D would be called non-rigid. Fluid, yeah. Non-rigid. Non-rigid transformations. What makes them non-rigid?
It changes the shape.
It changes the shape because we're multiplying our x and y values. All right? Because we're multiplying, things are changing. We're going to graph letter D first. It's a little more simple. So I'm going to do letter D here. Is the 3 on the inside or the outside?
Outside.
So does that affect x's or y values?
Y.
Y values. What's it going to do to the y values? Multiply them by 3. So 3 times the y value. Is anything happening to the x?
No.
Excuse me. So the x is staying the same. And we are going to multiply the y coordinates by 3. So you'll notice I listed my ordered pairs right here. I kind of did that on purpose. These are the original ordered pairs, and what I want to do is transform that y coordinate. So what does -4 and -3 transform into? -4, -9. -1, 3 is going to transform into -1, 9. Very good. 2, 3 is going to transform into 2, 9. And 5, 0 is going to transform into 5, 0. Does not change because 0 times y is still just 0. So the x stayed the same and the y coordinate we multiplied by 3. So if you're looking at this little shorthand notation that I do, we're affecting the y coordinate. Is that a vertical change or a horizontal change? Vertical. The y-axis is our vertical axis. And what are we doing when we are multiplying by 3? What's happening? If you multiply by 3, did the numbers get bigger or smaller? Bigger. So that's a stretch, okay? So this is a vertical stretch by a factor of 3. Factor of 3. The word factor means multiply. So we are taking our y and multiplying it by 3, and that's what factor of 3 means. Multiplied by 3. So I can plot these points. -4, -9 is like here. -1, +9 is like here. 2, 9. And 5, 0 stays where it is. And you can see, like, here was our original range was from -3 to 3. And now our range is going all the way from -9 to +9. It's stretched all right. It's much bigger. Okay, so there is our letter D graph. Now, the last one, letter C, how many transformations do you see? 3 transformations. Very good. What's happening to the x coordinate? Multiply by half. Very good. Remember, everything with x is inverted. We need to flip that fraction, so we are going to take the x and multiply it by a half. What is that called? What are the words for that? Horizontal compression. A horizontal compression by a factor of a half. All right, now what's happening to the y coordinate? Multiply by a -1, very good. And what else? And down 3, very good. So those are two transformations on y, and I can shorthand that pretty easily. I have to multiply by -1, so I'm going to do -1 times my y. And how do you do down 3? -3. That's all it is subtracting 3. And so we can do that all in one nice tight package, okay? -y, subtract 3. So looking back at my ordered pairs, my original ordered pairs, -4, 3 is going to transform into, what does the x change to? -2. And the -3 is going to, let's see, -3 times -1? 3 minus 3? 0. Using this point, -1, 3. What does the x morph into? -1/2. And then we have 3 times -1. -3 minus 3? -6. Very good. Third point was 2, 3. What's half of 2? 1. And then we have 3 times -1. -3 minus 3? -6. And then using 5, 0. What's half of 5? 2.5 or 5 halves. 2.5 is a little more, I don't know, easy to graph, I guess. All right, and then -1 times 0. 0 minus 3? -3. So those are our transformed function, and I just get to plot those points. So -2, 0. -1/2, -6. 1, -6. And 2.5, -3 is right here. So we already said that it was a horizontal compression by a factor of a half. You can see here was my original graph that went from -4 to 5. And now you can see how it shrunk horizontally. It smushed in a lot. Okay, so it's half as wide. And then it also had a vertical reflection and shift down 3. So a lot going on there. Do you have questions on that? Pretty good? Okay, good.
I think we're ready for our worksheet.
Awesome, because we're going to do one more example and then we can get started. All right, example 2. These points, I'm sorry, -1, 6. And this point was 3, -2. Just draw the parabola and label the points is really all you need. Use the parent graph to write the equation for the graph shown. So we're going to start with our knowledge of parent graphs and parent functions, and our knowledge of how we can slide them around on the graph, translate them left, right, up, and down. But then these graphs also have an extra transformation, something that's going to stretch them out of shape. And so we have to figure out what that vertical stretch component is, vertical stretch or shrink. So it's a little bit of a small process, but hopefully it'll be just fine. So looking at our first graph here, what is the parent function? Y equals x squared, very good. And y equals x squared was normally right here, right? So there was our normal y equals x squared starting at the origin. And what do we have to do to our parent function to get it to slide and move so it lines up with our graph we see? Down to right 3. So it's got to move to the right 3 units, and it has to move down 2 units. So if it's moving right 3, how do I change this function to reflect that shift to the right 3? X minus 3, and then square. Okay. So when we see x minus 3, we know that that would be a shift to the right 3. Okay. And how do we reflect the down 2? Minus 2 goes on the outside. Very good. So left and right was an inside value. So inside with x, that's why we needed the parentheses being squared. Okay. And then if it's up and down, then that's an outside number, which is why we have the down 2 on the outside of our function. So that's really, really good. So that took our problem and shifted it right 3 and down 2. So now we know we're going to line up with that point. However, what we don't know is if everything else lines up just perfectly, because our problem might have been stretched or shrunk in some weird way, which means there's this value that I don't know what it is. So how do you think we can figure out what that number in front is? Any other things? All right. We need to figure out what our vertical stretch or shrink factor is in K. Shrink, stretch and shrink. There's something that's multiplying our little parent graph here to stretch or shrink it out of shape. And we need to figure out what that value is. Any thoughts?
Can you repeat that, please?
I'll give you a hint. We already used this ordered pair. Use the other ordered pair. That's why they gave them to us. Whenever you're given an ordered pair, they're giving you answers. They're giving you an answer for X and an answer for Y. Knowledge that we can use in our formula. So we're going to plug those values in. Plug in the 6 for the Y and the -1 for the X. And you'll notice when we plug in for X and Y, what is that going to allow us to do? Solve for A. All right, the solving turns out to be like the hard part. But let's start on the inside. -1 minus 3 is -4 being squared minus 2. And then what do we have to do? Square the exponent. So -4 quantity squared. 16. So we have 16 times A minus 2 equals 6. And then we can add 2. So we get 8 equals 16A. And then divide by 16. A equals 1/2. Is this an equation for our parent function?
Yes.
Yeah, it is.
No.
Oh no, this would be an equation for A. Right? So what do I need to do with this value? Yeah, plug it right back in, right there. So we get Y equals 1/2 quantity X minus 3 squared minus 2. And this is our equation for our parabola. Can you check it?
Yes.
What should you do?
Graph it.
Because when in doubt. So we can plug in our formula that we just found. 1/2 quantity X minus 3 squared minus the 2. And I can graph it. Looks pretty good. And then what am I going to actually check? Trace. I can use trace. And I'm going to test these points. When I plug in the 3, I get the 2, yay. And when I check -1, it gives me the 6. So I know I did it perfectly correctly. Okay? All right, one more. Ladies and gentlemen, we have another graph here. What is its parent function? Y equals X cubed. Very good. Y equals X cubed looks like this normally. And so you can see that our function has been slid over and up. How is it being slid? Almost. There we go. All right, I can't spell today. Right 4 and up 3. If we want to move right 4, how do I make a change to my parent function? X minus 4, good. And we need to cube that, all right? And then if we go up 3, where do we put that number? Plus 3 on the outside. What's missing? The A. You'll notice here, our function needs to be flipped, and it's going to be stretched or shrunk somehow. So what should we do to figure out the A? Plug in what? 3 and 5. So we have 5 is equal to A, 3 for the X. I'm so glad it's Friday. Okay.
3.
All right, 3 minus 4 is -1 being cubed. Don't forget that's most people leave off the power, which causes a lot of problems. What is -1 quantity cubed? -1A plus 3 equals 5. And then we need to do what? Subtract 3. And divide by the negative. What's A? What is it?
Oh yeah, never mind.
Okay, -2. Are we done?
No.
No. Plug it back in. Place of A. Y equals -2. X minus 4 cubed plus 3. All right, and again, you can check that really, really easily. Do you have any questions for me? All right, do the worksheet and then the bookwork on the back. And get it done before you leave.
Saw.